I welcome you for process heat transfer lecture. First I will define what is heat transfer. Heat transfer is a science which deals with the transfer of heat from hot substance to cold substance or hot material to cold material. The transfer of heat is due to driving force. The driving force in heat transfer is temperature difference. For example, if you take two bodies, one is hot, another one is cold, you assume that the temperature of the hot body is around 80 degrees Celsius and the cold one is at 20 degrees Celsius. Here, the temperature difference between hot and cold is 50 degrees Celsius. Till how long the heat transfer takes place? The heat transfers from this hot to cold when both hot and cold bodies reaches equilibrium. That means this is temperature difference, this 50 degrees Celsius, when both the hot and cold bodies will attain the same temperature. For example, 40 degrees Celsius and 40 degrees Celsius. If you see, the temperature difference at this point is 0. This is called as equilibrium state. The application of heat transfer, it has a lot of application in environmental engineering, climate change, metallurgy, in a lot of process industries where this heat transfer is involved. Next I will tell you the modes of heat transfer. There are three modes of heat transfer. The first one is conduction. Second one is convection. The third one is radiation. The conduction mode of heat transfer takes place in solids, whereas conversion heat transfer takes place in fluids. We know that fluid is nothing but liquid or gas. You know this radiation. So radiation, heat transfer occurs transfers in vacuum also. First, I'll tell you what is the conduction. Conduction heat transfer. The medium required for conduction heat transfer is solid. In solids, what happens means when the solid material is subjected to heat, the molecules which are present in the solid material attains thermal energy. Due to the thermal energy, these molecules will vibrate and the heat transfers from one molecule to another molecule. Likewise, the whole solid material gets heated. Next is convection. Convection heat transfer classified in two types. One is natural. The other name for natural is free convection. The second one is forced convection. In natural free convection, the heat transfers is due to the difference in buoyancy, where the molecules, the fluid molecules gets heated, the heated molecules density decreases and it moves upward, whereas the higher density particles will occupy the space. Likewise, a circulation current was created naturally due to buoyancy and the heat transfer takes place. For this, good example is heating of water in a vessel. In forced convection, the heat transfer due to external agencies such as agitators, impellers, pumps, blowers and so on. Then if you see in natural or free convection and forced convection, the rate of heat transfer is higher in forced convection because the velocity is increased and the rate of heat transfer also increases. The last one is radiation heat transfer. The radiation heat transfer is transfer of heat energy in space by means of electromagnetic waves. Electromagnetic waves. A good example for this, the solar energy what we are receiving from the sun. Next, I will talk about thermal conductivity. Thermal conductivity is denoted by letter K. Thermal conductivity is defined as the material which is having the ability to conduct heat. The materials which are having high thermal conductivity values, we call it as good conductors. Those materials which are having low thermal conductivity values are called as insulators. For example, for good conductors of good heat conductor is copper, silver, aluminium and so on. These materials which are having very low thermal conductivity values are used as insulating materials in engineering purpose during design or fabrication of equipments. Now I will tell you how the thermal conductivity varies with respect to change in temperature. By this equation, you can see this A plus Bt. This is the way the thermal conductivity varies with respect to temperature. This A and B are constant and T is the temperature, K is the thermal conductivity. Next I will tell you the thermal conductivities of metals, that is solids, liquids and gases. Solids will have, or generally called as metals, will have more thermal conductivity value than liquids. Liquids will have more thermal conductivity value than gas. Next I will tell you how the K value changes with respect to change in temperature. For metals, if temperature increases, the K value decreases. Whereas in liquids and gas, when temperature increases, the K value for the fluid increases. Okay. Next I will start with conduction, mode of heat transfer. In detail we will discuss about conduction. Already you know that conduction heat transfer takes place in solids. We should know how much heat is transferred in a solid material. For that, Fourier law of heat conduction is involved here. The statement for Fourier law is that the rate of heat flow is directly proportional to the area of heat transfer, temperature difference, and inversely proportional to the length of the path of heat transfer, that is dx. Okay. Next we should remove the proportionality constant. That is proportionality directly proportional, and you are incorporating proportionality constant K value. That is, then the equation becomes phase 1 Ka dt by dx. In this is that is Q is equal to Ka dt by dx. In this equation, we have to incorporate the negative sign. The reason for incorporating the negative sign is to get the final value of the Q will be in positive, because when the heat flow is proceeding or taking place in the solids, when there is increase in thickness and there is decrease in heat flow. So we are incorporating this negative sign, and the final equation for Fourier's law for heat conduction is minus Ka dt by dx, where Q is the rate of heat transfer, which is in watts, K is thermal conductivity, watt per meter Kelvin, A is the area in meter square, temperature difference in degrees Celsius or Kelvin, and dx is the thickness of the material. With the help of this Fourier's law, we can able to derive the heat conduction expressions for different geometries. For our lecture, we are going to take consider the heat transfer through plane 1, the second one, composite one, the third one, heat conduction through cylinder, hollow cylinder, then composite cylinder. In next lecture, I will tell you how to derive the heat conduction equation for plain wall and composite wall. Thank you.